Hi guys, okay, here we go. Today we're going to do a review of trig functions. The stuff on top you should copy down. Remember, you can print this. I uploaded this, or you could be taking notes with me. Okay, so first let's fill out the stuff up top. Remember our special angles chart? And the way we would fill it out? The first two rows would all be over 2. And then it's 1, 2, 3. 3, 2, 1. All the numerators get radicals, but it wouldn't make sense to put a rad on top of 1 because rad 1 is 1. And then tan is sine divided by cos. So I always like to fill out this one first because rad 2 over 2 divided by rad 2 over 2 is 1. Now you could derive the other ones, 30 and 60, doing sine divided by cos, and do your complex fraction, which I always call top bottom. Or you could just remember that they're both rad 3's, but the first one is also over 3. Okay, so we have to remember our 30, 45, 60 chart. The next thing you need to remember is your All-State Teachers College. Remember, this is who's positive in the specific quadrant. So in quadrant 1, all of them are positive, sine, cos, and tan. In quadrant 2, just the sine is positive, so therefore cos and tan are negative. In quadrant 3, tan is positive, so therefore sine and cos are negative. And in quadrant 4, cos is positive, so therefore sine and tan are negative. And then we'll talk about the reciprocal functions as we get to them as well. Yeah, you know what, reciprocals are probably in here, so we'll just put it in now. So remember, sine goes with cosecant. Cosine goes with sine. Remember I taught you to memorize like a C goes with an S, and tan goes with cotan. And remember, these guys are the reciprocal functions. So if I give you cosecant, then you're doing 1 over the sine, and so on, okay, because they're reciprocal functions. So I did like I did in class. Oh, one more thing, reference angles. In order to find the reference angle in quadrant 1, you are your own reference angle. In quadrant 2, it's 180 minus the given angle. And in quadrant 3, it's the given angle minus 180. And in quadrant 4, 360 minus the angle. Notice 270 is never used. Okay. First two I did because those I think you probably would remember. Express degrees to radians. Some of we multiply by pi over 180. What are you going to put in your calculator? You can put 220 divided by 180, right? Because they're on top of one another. And the same thing with number 2. I want you to convert now from radians to degrees. So now we multiply by 180 over pi. And then the pi's cancel. So those are our basic conversions that you do want to remember how to do. Okay, next. Find the exact value of tan 240. Okay, so first thing we're going to do is draw a picture and see where is 240. Okay, so let's see. If I go to here, this is 90, 180. If I go all the way, it's 270, so I'm going to stop about here. And remember, my reference angle, definition of a reference angle, is between the terminal side where it ends and the x-axis. So if we go back up top, this is quadrant 3. So if we go back up in quadrant 3, we can see that it's the angle minus 180 to get your reference angle. So 240 minus 180 is going to give me a reference angle of 60. And then all state teachers. So tan is positive. So I'm going to really find tan 60. Go back up to our chart. Tan 60 is rad 3. Okay, next, find the exact value of sine 495. So if we want to find the sine of 495, remember, we're going to subtract 360 and make the angle between 0 and 360. So I'm left with sine 135. And now we start the process all over again. So where would 135 be? So 135 would land right here. My reference angle is between the terminal side and the x-axis. You can look back up on what to do for your reference angle. Now I'm in quadrant 2, so 180 minus theta. And and I get a reference angle of 45. All state sine is positive, so this will be positive sine 45. Go back up to your chart, rad 2 over 2. Okay, hopefully that went well. We remembered that. I feel like you probably did. Okay, another exact value. This time I'm giving you a negative angle measure. Remember when we have a negative angle measure, you just keep adding 360 until it becomes positive? So I wound up with cos 240, and now we start the whole process over again. Let's draw our picture. Where does 240 land? Right in here. Reference angle between the x-axis and the terminal side. In order to find the reference angle in that quadrant, we subtract 180. I'm left with 60. All state teachers, only tan is positive. So therefore, this is going to be negative cosine of 60. So this will be negative 1/2. All right, number 6. If cosine of A is negative 8/17 and cotan of A is greater than 0, cotan A greater than 0, doesn't this mean that the tan is positive, right? We want to be able to use our All-State Teachers College. So cotan and all the reciprocal functions are not in there. Or we want to know which quadrant it falls in. Okay, so let's do this part first. This is telling me cos is negative. So cosine is negative here and here. Tan is positive. That would be quadrant 1 and 3. So where does the overlap occur? It occurs in quadrant 3. That's where both scenarios take place. Okay, 8. Okay, we're skipping 7. We're going to skip some of these. All right, 8. Find the value of the cosecant of 5 pi over 6 minus cosecant of 3 pi over 2. Okay, so I'm going to use all this space here. So the first thing I'm going to do is convert to degrees. You can throw in your calculator 5/6 times 180 if you want to, or you can do it out with me. 6 goes in once, goes in 30 times. 5 times 30 is 150. So I'm trying to find the cosecant of 150 minus, now we'll do the other guy, 3 pi over 2. I think we all should remember that's 270, right? So cosecant of 270. Okay, so let's use this space still over here. So what I really need to do is find the sine of 150, and then I'll do the reciprocal. That'll be the cosecant of 150. So just like we've been doing on the previous questions, 150 lands right here. All state, so sine is positive. Reference angle, 180 minus 150. So I'm trying to find the sine of 30. Sine of 30 is 1/2, so the cosecant is the reciprocal, which is 2. So this is 2 minus. Okay, now we'll do the same thing for cosecant of 270. So I'll find the sine of 270, and then I'll flip it. That'll be the cosecant. So it's sine of 270. You guys could do that whole thing where you use the unit circle and you remembered what the points were, right? Or what I like to do is just think about the sine wave. If I had a place to draw. Okay, I'll come over here. So remember the sine wave? And this was 0, 90, 180, 270. So at 270, it was -1. What's the reciprocal of -1? Well, the reciprocal of -1 is -1. And think about why. Any number you can place over 1. So now to the reciprocal, -1. Okay, and then 2 minus -1, my answer is 3. Okay, that was toughy. Not sure if you remembered that one. Skip 9. Number 10, I did already because I think you would remember this. I was asking for coterminal angles. So coterminal angles are you just can keep adding 360 or subtracting 360, and there's an infinite number of coterminal angles. So I just gave you 2. Remember, you land in the same exact spot. Number 11, on the unit circle shown in the diagram below, sketch an angle in standard position whose degree measure is 330. Find the value of cotan of 330. Oh, I think that's supposed to say, is it supposed to say that? Hold on one second. Yeah, I think that was supposed to say cosine. Okay, change that to cos. Okay, so where would cosine of 330 be? So 330 is going to land here, right? My reference angle is going to be 360 minus 330. So my reference angle will be 30. Cosine is positive. So I'm really looking for, I forgot to cross this out too. So I'm really looking for just the cosine of 30. And the cosine of 30 is rad 3 over 2. Okay, so just make sure you make that change. Okay, the line segment question. I'm just reminding you of what it was when we did the derivation with the unit circle. So remember we tried to get to this point right here? You probably don't remember, but we were trying to get to this point on the unit circle. So when you travel in the pink direction, that's the x-axis, and that was our cosine. And when we traveled upward, that was my sine, my y value. So just facts. Okay, 13, the Pythagorean identity. I think you do have this memorized for me. Cosine squared plus sine squared equals 1. And then if I were to subtract cosine squared, right, subtract cosine squared, you can see you would be left with sine squared equals 1 minus cosine squared. And if we did it the other way, we would be left with this too. So if you could memorize those two purples, this guy and this guy, that would be great. And I assume that we already have this one memorized. Okay, 14 and 15. So 14 we notice is dots. Take the first one and square it. Take the second one and square it. Put a minus sign between it. And look, 1 minus sine squared, right here it is cosine squared. So just memorization. And then the next one, dots again. Take the first one and square it. Take the second one and square it. Put a minus sign between it. And look, 1 minus cosine squared is sine squared. So just using the Pythagorean identity. 17, in the unit circle shown at the right, what are the coordinates of A? So if I want to find the coordinates of A, and that's a 240 degree rotation. Remember on the unit circle, it's always cosine sine. So let's find the reference angle for 240, which will be right in here. So 240 minus 180 is 60. All state teachers, so that means this is negative cos 60, comma, negative sine 60. And then right from our chart, negative 1/2 and negative rad 3 over 2. Okay. I think we're skipping, oh no, we are doing these. Okay, 18. So 18, let's draw the angle and label the reference angle. So just a little practice. 300 is right here. And then they want me to label the reference angle. So this reference angle right here, 360 minus 300, so we got 60. 160? Well, so this part here is 180, so 160 is going to be about here. And my reference angle will be 180 minus 160, so 20. And now I gave you a radian measure. So if I give you a radian measure, we have to convert first. So 225, oopsie, is going to land about here. So my reference angle, so I'll do 225 minus 180, and I'm left with 45. Okay. Okay, so just a little practice with reference angles. Skipping 19. Okay, 20. So 20 says the terminal side of an angle in standard position, the terminal side of theta, an angle in standard position, intersects the unit circle. So as soon as we see unit circle, we know it's cosine sine. What is the value of sine? What is the value of the secant? Okay, well, the value of the sine is right there. Sine is 1/2. Okay, now secant. In order to find the secant, it's going to be the reciprocal of the cos. So it'll be -2 over rad 3. But remember, we have to rationalize the denominator. So the secant will be -2 rad 3. Rad 3 times rad 3 is rad 3. Okay, now 21 is a little different. 21 does not say anything about the unit circle. So therefore, that is not CS on top. So I cannot do this. That would be wrong. It is not the unit circle. So we draw a picture instead. So I graphed the point -8, 6. Here it is. I went -8 this direction, right? And then I went up 6. So if we extend out, drop down. Now I went -8, up 6. This is a 6, 8, 10 triplet. So I know this guy is 10. You could do Pythagorean theorem if you want to. And now I want the sine, and I want the cosecant. So we'll use SOHCAHTOA. So sine is going to be opposite over hypotenuse. Remember, here's your angle. So 6/10. And then I want the cosecant. So cosecant is the reciprocal of the sine. So 10 over 6. And you don't have to reduce those. You could leave them like that. Okay, 22. A circle centered at the origin has a radius of 10. The terminal side of angle theta intercepts the circle in quadrant 3 at point M. Okay, so I'm in quadrant 3 somewhere. There's my point M. Remember, when you create your right angle, the right angle always touches the x-axis. Now it says the y-coordinate is -6. So wouldn't that be this, going down to -6 to get my y-coordinate? And the radius is 10. Remember, this is really your circle. So that's why that's your radius of 10. And again, I have a 6, 8, 10 triplet. Yes, this is 8, but that's negative, right, going in the negative direction. They want cos and tan. We'll use SOHCAHTOA again. Cosine is adjacent over hypotenuse, so -8/10. And tan, opposite over adjacent. Now when I do tan, opposite over adjacent, -6 over -8 is going to give me +6 over 8. Okay, 23. 23, I'm telling you that the angle lies between 180 and 270. So that means I'm in quadrant 3. So we'll extend out. I'm giving you the sine. Sine is opposite over hypotenuse. So opposite over hypotenuse. And then who gets the negative? Well, the radius, the hypotenuse is always positive, so the negative goes with my 7. And now here I do need to do Pythagorean theorem. Remember, always put in that hypotenuse first. The other two values don't matter. So negative rad 7 squared. 7 plus x squared equals 16. X squared equals 9. X equals plus or minus 3. So now which one would it be? To the left is negative, so -3. And now my cos is adjacent over hypotenuse. So cosine is going to be -3/4. Okay, good stuff. I hope you guys remember this. You know, pause it and you can go back again if you need to. All right, almost done. 24, I did some of it. Using the identity, find the value of cos and tan if sine is -0.7 and x lies in quadrant 4. Okay, so I started it. I'm just going to remind us that we're in quadrant 4. Okay, so I substituted in my sine value, right? And then I got to the point of cosine squared x equals 0.51. So from here, I'm going to take the square root, and I'm left with cosine x equals, remember, plus or minus rad 0.51, right? Anytime we're taking the square root of a squaring. Okay, and now we're going to decide if it's plus or minus. So we're in quadrant 4, so cos is definitely positive. And now I want to find it to the nearest hundredth, so I'll plug that in my calculator. And to the nearest hundredth would be 0.71. And then they also want me to find tan. So tan, remember what tan is? Tan is sine over cos. So tan is going to be -0.7 over, and now you want to go back and use the radical, 0.51, so you can get a real close correct answer. And once you plug that in and round, we get -0.98. Okay, so that's an important one that you should know how to do. Okay, and then I think 25 is our last one. Okay, here we go. If the terminal ray of theta lies in quadrant 4, and I tell you what tan is, and we know the Pythagorean identity, find cos, secant, and sine. Now notice they didn't say that you have to use it, right? They're just stating it. You can decide whether you want to use it. Okay, so we're in quadrant 4. Extend out, right angle, touches the x-axis. Here's theta. SOHCAHTOA, so opposite over adjacent. So opposite over adjacent, and then you decide who gets the negative. Going down is negative. This is also a triplet, 8, 15, 17, if you want to memorize it. So we don't really have to use the identity. You can if you want to. Some kids like to, but you don't have to. All right, they're asking for cos, secant, and sine. Okay, so we'll just use SOHCAHTOA. So cosine is adjacent over hypotenuse, so 15 over 17. Secant is the reciprocal of the cos, and sine is opposite over hypotenuse. Okay? All right, I hope that was a good review for you guys, and then we'll do a review of trig graphs tomorrow, and then there'll be a little delta assignment for you. Okay? So great job, guys. Really proud of you for doing this whole course like this and reviewing with me. All right, bye.